our next topic is about proof, and we'll spend about 2 days talking about how to prove something logically is always true. In this video and in the next lesson, we'll talk about algebraic proofs and proofs with constructions. In this lesson, we're covering one CCRSM standard, and that is to prove theorems about lines and angles. Theorems include vertical angles are congruent. Now, I must be honest, and there is something about this standard that makes me a little bit nervous, and that is, it says prove theorems, plural, about lines and angles. Theorems include vertical angles are congruent. So, it's not just the one theorem that vertical angles are congruent, but prove theorems that are like this one. And so we'll need to be exposed to several different kinds of proof so that you're ready to prove theorems that are about lines and angles. And so we'll cover several of them in this video, and we'll look at several more tomorrow during class. The lesson starts out by talking about deductive reasoning, which is the kind of reasoning used in proof, reasoning based on accepted facts. And so we're using the fact that the angles of a triangle sum to 180. And we're seeing if we can prove that a plus y equals z in this diagram. Okay? Now, we can use things about triangles and some algebra to do this. So we'll start off by, so here's the proof. We start off by labeling angle W. So we'll say, well, this angle that's in here, this angle right here, I'll give it a name. I'll call it angle W because I want to talk about that angle. And so I next say that angle X plus Y plus Z must equal 180 because, let me say because, the sum of the angle measures in a triangle is 180. And so we know that's true. Now we also know that because angle W and angle Z are a linear pair, they must add to 180. They must be supplementary. So the next statement is angle W plus the measure of angle Z adds to 180 because they're a linear pairs form supplementary angles. And we're going to use those two facts and some algebra to then deduce or use deductive reasoning to say that X plus Y must equal Z. Now the next thing we do is say, well, they both equal 180. That's the same number. And so this and this must equal each other. And so I put this on this side and this on that side, and they must equal each other. And the reason, because of the substitution property of equality. I can substitute equal things in and it will stay equal. That's the substitution property of equality. We'll use that several times over the next day or two, especially today. These three dots mean therefore. Therefore is kind of a long word, and it's used a lot in proof, and so mathematicians have decided to just write 3 dots, means therefore. And next we're going to say, well, we notice that angle W is on both sides. So I can subtract whatever number that is, I can subtract it from both sides, and I'm left with what I wanted to prove, which is the measure of angle X plus the measure of angle Y must be equal to the measure of angle Z. And the reason is because of the subtraction property of equality. I can subtract equal things from both sides and they will stay equal. Now, that's using deductive reasoning. I'm logically going step by step why something is true, and I'm hoping by now you're convinced that the measure of X plus Y plus must equal angle Z. And by the way, what this is this is the proof for the exterior angles theorem. All right, so now we can use the exterior angles theorem whenever we want because we've proven that it's always true. Okay, that's our first look at a proof. Let's look at another one, which is about vertical angles. So here, exercise 1 is the standard, is the question that's talked about in the standard. So this is a very important one to memorize. I would put a standard star next to this question. This is a question that might show up on an exit ticket. It might show up on an exam because this one is specifically mentioned in the standard, but you have to know others as well because others in the standard it says theorems like this one. So this one, we are asked to prove that vertical angles are equal in measure. Now, to help us think through how to go about proving that, we will look and think about what things do we know about angles W and X and Y and X to kind of help us. Well, we know that W and X are right here. They form a linear pair. And because they're a linear pair, I know that the measure of angle W plus the measure of angle X must equal 180 degrees. What do you know about angle W and X? Y and X, these two. Well, these are also a linear pair, and the measure of angle Y plus the measure of angle X equal 180. Okay, and that's all I can really think about of things I can use with W, X, and Y. And the next bullet point to help you think through this is what conclusions can you draw based on both pieces of knowledge? Well, I'm going to use the fact that these are the same and these are the same. Does that make sense? So if those are the same, if these are the same, both says the measure of angle X, and these are both 180, then we can deduce or use deductive reasoning to say, well, then these two must be equal as well. And that's kind of where we're going. We'll do it a little more formally than just talking about it, but that's the essence of our proof. Okay, so let's write out the proof. We will begin by saying our first line. The measure of angle W plus the measure of angle X equals 180 because linear pairs are supplementary. I will also say that the measure of angle Y plus the measure of angle X is 180 for the same reason. Next, I'll do something very similar to what I just did in the previous proof and say, well, they both equal 180, so by this substitution property of equality, that the measure of angle W plus the measure of angle X must equal the measure of angle Y plus the measure of angle X. Now I will again do something similar to the previous proof, where I subtracted the same thing from both sides and it stayed equal using the subtraction property of equality, and I will subtract the measure of angle X. And that is our proof. We've proved that angle W and angle Y are equal, and because we did it using variables and not a specific example with numbers, we can say that's true for all vertical angles. And so we've proven that vertical angles are equal in measure, and that's the whole proof. Next, I want to talk about a different kind of proof. These are proofs with constructions, which means you'll draw a line or more than one line either before or during your proof. And these lines have a special name. They're called auxiliary lines. They are when you draw or extend segments, lines, or rays, is frequently useful in demonstrating steps in the deductive reasoning process. So when you draw a line during a proof, it's called an auxiliary line, and you are able to draw an auxiliary line at any point during your proof, and it helps you show something. So to give you one example of a proof that involves an auxiliary line, down here there's a proof where you are given that segment AB is parallel to segment CD. And this symbol right here means parallel. Those lines are parallel. And we are asked to prove that the measure of angle Z is equal to the measure of angle X plus the measure of angle Y. Now we're going to draw an auxiliary line. And actually, on the next page, it shows you there are two different ways to prove this using two different auxiliary lines. Here is one possible proof that uses an auxiliary line. You extend this transversal down through segment CD. And what we've created here is a triangle. And we know that the angles in a triangle add up to be 180 degrees. And we're going to use that in our proof. Now, before we begin, we always start with a given. So I will start with that AB is parallel to CD because it is given. Now, I must figure out what else is here that I can use to prove that the measure of angle Z is equal to the measure of angle X plus Y. Well, I know that I have parallel lines, and I know things about parallel lines. One of the things I know is that corresponding angles are congruent, and that angle X and angle V are corresponding angles. So I will say that the measure of angle X is equal to the measure of angle V because they are corresponding angles. Next, we have to look at other things that are in this proof that we can use. And the next thing that I notice is that angle W and angle Y are vertical angles. And previously in this video, we proved that vertical angles must be congruent. So I can say that the measure of angle W is equal to the measure of angle Y because vertical angles are congruent. Next, we'll look at how angles Z, V, and W are related. Previously in this video, we proved that when there's an exterior angle to a triangle, that angle is equal to the two remote interior angles. So what that means is the measure of angle Z is equal to the measure of angle V plus the measure of angle W. Next, we'll look at, we've talked about V and W and Z quite a bit, and we can actually substitute, let's see here, X in for this V, and we can substitute Y in for this W, and what we get is that the measure of angle Z is equal to the measure of angle X plus the measure of angle Y by substitution. And this is exactly what we are being asked to prove, that Z is equal to X plus Y. So that is the end of our proof. So this lesson is our first introduction to proof. We looked at algebraic proofs, proofs that kind of use equations and some properties of equality to solve them, to prove them. And we also talked about proofs with constructions where you draw in some auxiliary lines to assist you in proving something is always true. Thank you for watching.